Welcome everyone to my LeetCode weekly contest 418 live stream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be doing the contest live and answering questions and giving hints in the chat. So come join us every weekend for the contest. We will never share code during the contest, but immediately afterwards, we will go through solutions for all 4 questions. So make sure to stick around. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright, so we have about 6 more minutes before contest starts. And I'm going to warm up by doing today's problem of the day. Let me see who's around. Okay, so today's problem of the day, sentence similarity 3. You are given 2 strings, sentence 1 and sentence 2, each representing a sentence composed of words. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. Each word has only upper and lowercase English characters. 2 sentences are considered similar if it's possible to insert an arbitrary sentence inside one of these sentences such that the 2 sentences are equal. Note that the inserted sentence must be separated from existing words by spaces. So basically, if I think of the sentence as a list of words, then what this means is that we have one sentence must be like a subarray. Or it's not a subarray. Insert an arbitrary sentence inside one of the sentences such that 2 sentences become equal. Okay, so basically what happens is we have to take one sentence, presumably the shorter one. We need to find a point let's say this is S1 is a shorter sentence. We need to find a point where you can break up S1 into 2. Where the first part of S1 is a prefix of S2 and the second part of S1 is a suffix of S2. We don't have to care. So there's this thing about inserting a sentence in between. Well, because S2 and S1 are both sentences, whatever we can insert in between is going to be a sentence. Yeah, we don't have to check that what we're inserting is a sentence. We just need to check that you can insert something in between. Either as the shorter one, let's say S1 is the shorter one, we have to check that you can get from S1 to S2 by inserting something in between. And all we have to do is to check that S1 is a prefix of S2 and the second part of S1 is a suffix of S2. So the way I'm thinking about it is actually n squared. I wonder if there's a faster way to do it. The way I'm thinking about it is n squared, because I basically would check each. I'll go to like each thing in S1 and just check if it is if it's a prefix of S2 And then I'll go to the last part and check if it's a suffix of S2. So it's kind of n squared. The other thing I can do is to find the longest prefix of S1, like the longest common prefix. So this is the longest common prefix. And then check that the remainder is a prefix. Yeah, I'll think about it. All right. I don't think this question is too difficult. All right, contest is going to start with 56 seconds. Oh, my time is wrong. My time is slightly wrong. So I have no time to actually solve that question. Let's see. This is going to be a quiet night. Okay, I see some people joining live stream. Welcome to everybody to live stream. Good luck for your contests. I hope everybody does well. Remember, if you have questions, type them in the chat. I will be paying attention to the chat. Remember not to ask for solutions or code. Not to share code. Remember not to share code during the contest, or LeetCode will ban you. Yeah, so don't share code. Don't use my channel to share code. I don't want to get in trouble, even though I'm a very small channel. All right, we're good to go. All right, good luck, folks. I'm coding on my second screen, so if you don't see me doing anything, that's not because I am asleep at the wheel. It's because I am coding on my second screen. So talk to me if you want something. So question 1, maximum possible number by binary concatenation. Oh, question 1 is a medium. Wow. Wow, this week is hard. At least the points are very high this week. Return the maximum possible number whose binary representation can be formed by concatenating the binary all elements of numbers in some order. Okay, this question is not too difficult. Hey, hi Rohan Sharma. Welcome back. Welcome. Yeah, the first question is not that difficult, but it's pretty difficult for... Yes, I would say it's pretty difficult for question 1 by question 1 standards. So ask if you need some help. You need to think a little bit about what number you put in front. You don't always put the biggest number in front. Like in the example, 312, you don't put the... You have 3 in front, but your next number is 1. It's not 2. So you have to think about what the word greater means, basically. More people coming in. Welcome to folks who just joined. The contest is live. Definitely work on the contest yourself. If you need help, let me know in the chat, and I would help you. I'll try my best to help you anyway. Start solving. I'm already solving. Yeah, I'm already solving, but it's on a different screen. So I don't share. I don't show my work while the contest is running, because competitive integrity. You're not supposed to show answers. So try it out yourself. And if you need help, I would just type in the chat and I'll try to respond to you. But unfortunately, I can't show my running screen because it is a contest. So I can't show any answers. All right. Yeah, sorry, Tyson. We don't show answers in this channel. But if you wait a while, we will discuss all 4 questions. Hey, Goku, welcome. Hi, bro. Actually, question 1 is quite interesting. Yeah, I'm surprised nobody asked for help on question 1. Yeah, I can't copy and paste answers. Unfortunately, I don't share. So we don't share code while the contest is running, because yeah, it's competitive integrity. But after the contest ends, we'll go through all the answers. Yeah, I think that is generally the rule. I don't think any other channel does that. I don't think any other channel shares code while the contest is running either. Huh, interesting. Hmm. First question is kind of tricky. First question is trying tricky. So what you want to do, the basic idea of what you want to do is you want to think about how to sort these numbers. You want to think a way to sort these numbers. So the numbers is 1, 1, 0, and 1, 1. First, you convert them to binary representation. You want to sort these three numbers in a way that will produce the largest number, right? So the way to sort this is basically you need to find what are the ones that have no zeros. Probably you want them to be first, right? 1, 1, 1. They have no zeros. Doesn't matter where you put them, they'll always be first. And then next thing you want to do is find out the ones with 1, 0. See where the first 0 is. You want as many ones as possible in front, and as few. Yeah, you basically want as many ones as possible in front. Yeah, or there's actually a simpler way to find this. Oh, actually, there's a much simpler way to find this. Because there's only 3 numbers, so we can kind of do it by brute force. So since there are only three numbers, you can probably do this by brute force. Let's see if this works. Okay. Nine four. Okay. Oh, damn. It is by brute force. I didn't notice that they were... damn it. I had a smarter way to do it, but there's... it's not that hard. It's only 3 numbers. So I kind of missed on that one. Yeah, if question 1 is only 3 numbers, you can just... You don't need to actually sort them. Question 2. You're maintaining a project that has n methods and numbered 0 to n minus 1. You're given 2 integers n and k. You're given 2 integers n and k, and a 2D array invocations where invocations I equals to AB. Wow. Okay, so method A invokes method B. This looks like a graph problem. What the heck? Oh, it's definitely a graph problem. So there's a known bug in method K. Method K, along with any invoked by it, directly considers suspicious, and we need to remove them. A group of methods can be removed if no methods outside the methods. Okay, so you have 2 integers n and k, and a bunch of invocations. So what this question is saying is that, okay, you basically are given a number of methods n, and then you have invocations, which is the call graph, which is basically a call graph is a weird way. It's basically a graph. You don't have to worry about the sort of fiction of, oh, it's a call graph or whatever. And then k equals to 1, and this is the bad guy. So basically, you need to remove everybody that points to k. Everybody points to k needs to go. So 0 points to k, 0 needs to go. Wait, hang on. Any method invoked by it are considered suspicious, and we need to remove them. Wait, why is... hang on, I'm not understanding this right. So method k, method 1 needs to be removed. Why doesn't method 1 have to be removed? It's suspicious. Method 1 are suspicious, but directly invoked by methods 3 and 0, which are not suspicious. I don't get it. Okay, method k along with any method invoked by k, directly or indirectly, are considered suspicious. So method 1 and 2 are suspicious. A group of methods can be only removed if no method outside the group invokes any method inside. So return an array containing all remaining methods. Okay. We return all the okay, I think the reason why we return all elements here is because it is not possible to remove all suspicious methods. It's not possible to remove all suspicious methods. Because once you remove all suspicious methods, all the methods will be gone. Okay. Let's see this one. So 0 is suspicious. 0 is suspicious, and if 0 invokes 1 and 2, they're all suspicious. So you can basically remove this whole thing. So you can remove this whole triangle. In this case, let me see. 2 is suspicious. So by extension, 0 and 1 are also suspicious. You can remove the whole triangle. And so the reason why you can remove the whole triangle is because, oh, I see. So basically you check two things. Yeah, you gotta check two things. One is you need to check that you need to find suspicious methods. And then 2, make sure no non-suspicious methods call suspicious methods. So that's what the question is asking for. So find all the suspicious methods and then make sure that the non-suspicious methods don't call the suspicious methods. So essentially it sounds like what it's trying to do is find a loop that goes back to it's not trying to find a loop. Yeah, so that's what it's trying to do. Oh, Livestream is very quiet tonight. Nobody is asking questions. This is so interesting. Okay, so this is a graph problem. So one thing I like to do in a graph problem is I like to turn an edge list into an adjacency matrix, because the edge list is such a pain in the butt to deal with. Okay. Yeah, so that's what I always like to do. And then, so what we need to do is find all the suspicious methods. And probably what I want to do is just start with K and then go down. So I don't know if this approach is going to be fast enough. It's a pretty brute forcey approach. I don't know if it's fast enough. I think it should be, because I don't see any big numbers in the question. So hopefully there's nothing weird about this question. There's no like edge case that caused this question to time out. First question. Hey, Sonu Lambda, welcome. So first question is kind of it's pretty direct, I think. So first question is asking you to take three numbers, turn them into a binary representation. So binary representation is going to be 1, 1, 0, and 1, 1, right? For 1, 2, and 3. This is the binary representation. And what you want to do next is you need to find the maximum possible number who can be formed by concatenating the binary representation. So just try 1, 1, 0, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, and then you concatenate each one and you see what it gets. So 1, 0, 0, 1 is like 2, 3, 3 plus 8 is 11, 11 plus 16 is like 27 or something like that. And this one is, this is just, I think 30, 30, and then, and so on and so forth. And you find the maximum of these ones. That's the basic idea. I think there's nothing very tricky about this, but I'm gonna leave you to work out the implementation yourself. Let me know if that is helpful. How to concatenate them? Okay, so Basan Agrao, it depends on what language you're using. So first you have to convert them into binary. And in binary, these will be strings. These are all binary strings. So in Python, you can use the bin function. In C++ and Java, I don't know. But you can probably look up on the internet. There should be easy ways to convert decimal numbers into binary string. So once you convert them into binary string, concatenate is just string concatenation. This should all be strings. Just do a string concatenation, and then like once you've done that, you have to do some kind of binary string back to integer representation. So Python has easy functions for doing that. If you're not using Python, you're using Java or C++, you can probably look up on the internet. They will help you. So question 2. Let me talk about question 2. So question 2 is basically a graph problem. It says you're maintaining a project with n methods from 0 to n minus 1. You're given 2 integers, and then you're given like this invocation, which is edges. This invocation is basically the edge list. And what you want to do is you want to say there's a known bug in method k, and you're essentially what you're required to do is, okay, there's 2 possibilities. One, you define all suspicious ones and then remove all of them. Either you remove all the suspicious guys, or if it's not possible to remove all suspicious methods, then you remove 0 methods. This is kind of a this doesn't actually make sense in if you're a programmer, but whatever. This is just a question. So you don't have to care that this is a method or this is a call graph or anything like that. This is just simply a graph problem. What it says is essentially you need to check which methods are suspicious. So in this case, k is suspicious. Everybody that k calls is also suspicious. So calls 2 is also suspicious. If 2 calls like 5 will also be suspicious. Okay, so find all the suspicious people. 2 is, second part is you want to check if you can remove all the suspicious people safely. So to do that, you basically look at, you want to check if anybody calls them. So in this case, these 2 are suspicious, but they are caught by 3 and 0. So because 3 and 0 calls them, it's not possible so you keep every bun. That's why the output is 0, 1, 2, 3. In the second example, k 0 is suspicious, 0 call 1, 1 also suspicious, 1 call 2, 2 also suspicious. So these 3 are suspicious. But guess what? Hey, nobody else calls them. So they can be safely removed. This is sort of like a, what do you call that? It's like a strongly connected component on its own. It's a connected component. So in this case, these 3 can be removed and these 2 are good to go. So the answer is 3 and 4. Yeah. So basically for this, the first part is you need to find all the suspicious methods. You know how to do this. You do some kind of graph traversal algorithm, right? Whether breadth first search, depth first search is up to you. Doesn't matter. And then the second part is make sure all the non-suspicious methods do not call suspicious methods. That's part 2. I hope that was helpful. Let me see, any other questions? Okay, so far so good. So we don't share code because the contest is still running. So I don't want people to just copy the code. And anyway, you don't want to copy the code either, right? Because that would cause problems. But if you want to see what the solution is, stick around. After the contest, we'll go through all four questions. So we can only do that after the contest ends. That's how it is for LeetCode. Not target start is disjoint. All right. So 2 questions done at last. It's taking a while, for sure. Okay, question 3. I don't know which one. I don't think I can solve both question 3 and 4. I'm going to be strategic about it and play the game a little bit. I'm going to look at both question 3 and 4, pick the one that I'm more confident in solving, and work on that one. You're given a 2D array edges representing an undirected graph having n nodes, where edges I equals to uv. Okay, cool. So construct 2D array grid that satisfy all nodes from 0 to -1 in cell, which, wow, which node appearing exactly once. Oh, wow. Two nodes should be adjacent cells horizontally if and only if there's an edge between them in edges. Oh. It's guaranteed that edges can form a 2D grid that satisfy these conditions. Oh, this is hard. Okay, so basically what this question is saying is that you are given a bunch of edges. So for instance, 0, 1, 0, 2, 1, 3, 2, 3. Okay. You're given a bunch of edges. And you want to... What do you want to do? You want to turn them into a grid. You want to turn them into a grid. Actually, this may not be that hard. You want to turn them into a grid. You want to place the 4 numbers inside a grid. So there's 2 tricky things. One is you don't know dimensions of the grid. That's one thing that's tricky. And then 2, yeah, I think that's tricky. And so you sort of like, if for instance you get a 0, right? 0 is connected to, you know that 0 is connected to 1 and is connected to 2, but you don't know where to place the 0. 0 can be anywhere. I think for this, let me see, my strategy is as follows. If it's a 2-dimensional grid, then what I know is there has to be corners. I'm going to start at the corners first. And corners, let's say corners, have only 2 neighbors. So if somebody is a corner, they only have 2 neighbors. Right? If this is like this, a corner will have 2 neighbors. Okay? The only exception is if it's a straight line. And then you have only 1 neighbor. Okay. So I think this is coming into shape. I think this is slowly coming into shape. Yeah. Okay, so basically everybody can have either, if you look at neighbors, everybody can have either 1 neighbor, 2 neighbor, or 4 neighbors. Specifically, either everybody has 1 neighbor, 2 people have 1 neighbor, and then everybody else has 2 neighbors, or 4 people have 2 neighbors and everybody else has 4 neighbors. So this will be a line situation, and this will be a grid, or rather like a rectangle. So so I think this is the plan. This is my plan for solving question 3. So basically, the plan is to start by identifying the corners of the grid. So Yash D1, which question are you talking about? I'm happy to just let me know. Are you talking about question 1, 2, 3, or 4? I can explain the question again. But let me go to question 4 first. Question 4. You're given an integer array nums of length n and an integer array queries. Let GCD pairs denote an array obtained by calculating GCD of all possible pairs. Whew, this looks hard. Running GCD of all possible pairs and sorting these numbers in ascending value. For each, you need to find the element. Okay. For each query, GCD pairs and sort these values in ascending order. For each, you find the element at. Oh, okay. Oh, this is hard. Greatest common denominator. So you have to find the pairwise GCD of all the possible values. So 2. Why is it 1, 2, 1? Sort these things in ascending order. Oh, wait. GCD pairs equals to I and J. Okay, all the pairs, yeah. And then for each, you have to find the elements that index. Oh, this is hard. I don't know how to solve this. I have no idea. Let me think about it for a second. I'm going to lose a bit of time, but it's alright. So, GCD. Yeah, you define the. I think you need to draw, because greatest common denominator. Basically, you need to draw a tree. You arrange them in a tree. So not a tree, like a DAG. So at the first level are all your prime numbers, and then the next level are the non-primes. I think so. I think this, you have to arrange them in some kind of tree. Is how I would do it. So for instance, here 1, 2. So 1 is at the beginning, and then 2, and then 4 and 4. So I want to find the GCD of this 2, 4. It's going to be this 2. If you arrange them in a tree, like a factor tree, where every number is connected to its factor. So this way, if I want to find a GCD of 2 numbers, I just find the first common parent. So like 2, 3, 6, and 4. So if, let's say these are your numbers. So 4 and 6, the common parent is 2. So you know the greatest common denominator is 2. Yeah, I think this is a way to find all the GCDs really fast. That's my plan. Because if you find GCDs normally, yeah, it's going to take too long. It's going to be too slow. Okay, but I think I'm not going to tackle this one first. I'm going to tackle question 3 first. Question 3 doesn't seem as difficult. Yeah, question 3, I'm probably going to do the edge list again. Yeah, 2 graph problems in 1 week. What are the chances? Actually, yeah, the chances are pretty high because LeetCode like their graph problems. Yeah, Yash D1, which problem? What question are people want me to arrange? Explain some question again. Let me know which question you need. Actually, I need to find out. I should figure out how to get timestamps on LeetCode on YouTube. This way, I can just plug in the timestamp of the live stream. And I can just bookmark it, and then jump back to that particular timestamp. Okay, let me see. Oh crap. Okay, so 2D grid matching graph. I'm just gonna show. Yeah, this is probably the way I'll do it. And this way, you can find all the GCDs very fast. You just do like a prefix tree, like a factor tree. Let me see. Okay, I'm trying to tackle question 3. So question 3 is interesting. I think if you can, if for question 3, if you're able to find all the corners, you should be able to be successful. Uh, oh, interesting. Okay, I think I can. I'm gonna focus a little bit on finishing question 3. I'm pretty sure I can do question 3, but I'm gonna need a bit more focus. So if I'm not super responsive to your question, I'm sorry about that. I will come back and look at the chat from time to time, but I have to focus a little bit. Sorry about that. So question 3 is all about finding the corners of the grid. If you can find the corners, you will be successful. Dot append current. Okay, well through. Current equals to V. If current all right. All right. There's some bug. There is some bug in my code. Wait a second. He's 1 2 2 2 2. Okay. So 0 4 3 2 1 3 4 3. So 0 1 3. Oh, I get it. Zero 1 3 2 4 0 1 3 2 4. Okay. So I got the first test case to work. Yeah, I think finding corners is the right strategy for question 3. Yeah. So I'm going to ask people not to ask for answers. Sorry, I'm going to remove your. So sorry, Kavi Rajan. I can't have people trade answers on this channel, or else I'm going to get in trouble. Yeah. We can do that after the contest. After the contest ends, we'll go over answers. But for right now, unfortunately, we can't. We can't do that. I am going to have to remove your message. I'm sorry about that. If you have questions, once again, ask for hints in the chat. Let me know where you're stuck, and I'll help you. I can't give out answers. So for question 3, I'm pretty sure the idea is to search for all the corners. So if you do corners, you would probably be successful. At least that's what I'm doing. And it seems to be useful. It seems to be working. So there are okay. All right. Let me know if you guys let me know what your progress is like. How are people doing? Are people done with question 1 and 2? Are people working on questions 3 and 4? So I would suggest question 3 is a bit easier than, in my opinion anyway. Question 3 is not that difficult. It's a lot of like annoying stuff. It's a lot of annoying stuff. But other than that, it should be quite doable. Oh, break. Okay. Return row. Oh, wait a second. Test case. Okay. 107. 107. Okay, this is not correct. Let me see, are there any questions? Hey, the problem code. Let me see. Can you give hints to optimize GCD pairing? I'm getting TLE. Okay. I haven't done question 4 yet, but I'll try to help. So for third problem code, I don't give out code on this channel. We never do. Yeah, we just don't give out code on this channel. But I will go through all the solutions after the contest ends, so stick around. I do give out hints though, so I'm going to give you a hint. So for question 4, I haven't done it yet. My guess is that you can use a factor tree. So if you arrange all the numbers into some kind of factor tree, this is my guess. I haven't done it yet, and I don't know if this is correct. If you arrange the numbers into some kind of factor tree where each number's parent or parents is its factors, like 6 has factor 2 and 3, then there is factors, then it becomes very easy to find somebody's greatest common denominator. You just go up the tree. So I think this is the strategy. I'm not sure because I haven't done it yet. So question 3 is a little bit easier. Basically, the idea is you have to find the corners first. So the corners have, if it's a rectangle, the corners have 2 neighbors. All the corners have 2 neighbors. If it's a line like here, then the corners have 1 neighbor. So if you see 2 guys with 1 neighbor, is a line. If you see 4 guys with 2 neighbors each, is a rectangle. And what you do after you get the corners is then you sort of like try and arrange these guys. So for instance, you identify these are the corners. So you see 0. Who are his neighbors? His neighbors is 1. So the next one is 1. 1 has 1 neighbor. It has 3. So you go to 3. And 3 has neighbor 2. And 2 has neighbor 4. Since 4 is another corner, you're done. So you need to use some kind of, so the way I did it is you need some kind of adjacency matrix. So same thing for this kind of rectangle. You find the corners. The corners have 2. So let's say you start with, you find 1. 1 is the corner, right? So 1, it has neighbor 0 and neighbor 5. So let's say you go to neighbor 0 first. And neighbor 0's neighbor is 5, right? So this is a 3. And then this is 2. This guy has 3 neighbors, so he's an edge. This guy has 2 neighbors, so he's a corner. So you sort of tell whether they are edge or corner or inside by how many neighbors they have. So 5 is also a 2, so it's also a corner. So now you have 1 row, 1, 0, 5, 1, 0, 5. So now you go to the next row. You look for 1, you look for his, because 1 is a corner, only has 2 neighbors, right? You look for his other neighbor, which is a 7. And then you do the thing. I hope that was helpful. So I can't give you code, but good luck. Yeah, so if you reach question 4, you probably got further than me, so congratulations. I'm assuming that you solved question 3 already. So question 4, I think it is using some kind of tree, but I'm not super sure. I don't know if I can finish question 3. I'm unfortunately not going to be able to talk much. I need to focus on getting question 3 done. Of only 15 minutes left. Okay. 105. Okay. So I managed to get the first row done. Damn it. I don't think I can be able to finish question 3 in the time allotted. Damn it. This is taking longer than I thought. Oh well. It is what it is. Row 2. Sorry again if I'm being quiet. I am scrambling. I am freaking scrambling to get this done. Before the time limit. I'm pretty close. And if I don't get this done, I will be pretty mad at myself. Seven more minutes. Can I get it done? So I'm very close to this. If v in use, continue. Else, if I'm looking for v in dude. Ah, damn it. I'm so close to this. Ah, damn it, I'm so close to this. Submit. Ah, damn it. Wrong answer. Ah, it's too bad. Yeah, I managed to get 63 out of 785 for question 3, which, you know, in the grand scheme of things, it's not that bad. All right, so the contest is over. Sorry about last minute scramble. It is what it is. While I have everybody here, just a bit of a plug for the channel. If you enjoy this channel, make sure you like and subscribe. That's going to help me a lot. If not, feel free to let me know in the chat what else you want to see. I'm always trying to make the stream a little more interactive for people. I'm done. I only managed to do 2 questions today. This is not a good contest for me. I'm very close to doing question 3. I'm pretty sure I can just get it done if I have a few more minutes. But unfortunately I don't. But I do have a good sense of what the solution is going to be like. So I'm going to go through the solutions for all 4 questions. Let me take a quick swig of water and come back. In the meantime, I will appreciate if people just like, subscribe, comment on the channel, comment on the stream video. That actually helps me out a lot. I'll see you in 1 minute. All right. Weekly contests tend to be a little bit less well attended by people, but you know, it is what it is. So let me quickly go over the solutions for, I guess, at least the first 3 questions. The last one, I haven't tried it, so I don't know what the answer is, but I'll try to go over solutions for first 3 questions. Okay, but before that, for the algorithm, we are discussing solutions for LeetCode Weekly Contest 418. Jump to specific questions using the timestamps in the video description. And if you enjoy LeetCode contents, remember to check out the rest of my channel, like and subscribe to stay up to date on new videos. Alright. For the folks who are still here, this is probably the moment that you've been waiting for. We're going to go through solutions for all 4 questions. This week's questions 1 and 2 are unusually difficult. They are unusually difficult by the standards of questions 1 and 2. So we will go through them, and hopefully they'll be meaningful in some way. Okay, so let's start by question 1. So question 1 is maximum possible number by binary concatenation. You are given an array of integers of size 3. Basically, you're given 3 numbers. What you want to do is return the maximum possible number whose binary representation can be formed by concatenating the binary representation of all elements in the numbers in some order. So one of the biggest difficulties about LeetCode question is reading the English, right? Read the English. So read the English, right? It is what it is. It's getting better at reading English text, precise technical language in English text is going to help you so much in life. It's going to help you so much in life. Okay, so what is this question talking about? Return the maximum possible number whose binary representation can be formed by concatenating the binary representation of all number elements in nums. So you want to take all 3 elements, you want to concatenate the 3 of them together, and you want to find the maximum possible number that can be done by concatenating, which means you can change the order, right? So step 1 is to find the binary representation of all three numbers. So for instance, here, let's say numbers is 1, 2, 3. It's going to be 1, 1, 0, and 1, 1, right? 1, 2, and 3 in binary. So how do you concatenate these things together? Well, you can do 1, 1, 0, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, and then so on and so forth. There are basically 6 combinations. So 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, and so on and so forth. There are 6 possible combinations. So step 1 is to take all the numbers, convert them into binary string. This is how you do it for Python. In C++ and Java, there are other ways to do it. You can just Google on the internet, they'll tell you how to do it. And once you've done that, you concatenate them together. This is how in Python you turn binary string to integer. Right? You take the binary string, you turn it back to integer, and you do it for all 6 combinations, and you take the maximum. So this question was so the key thing to know about this question is actually the fact that you have only 3 numbers make it easy. You can look at all possible combinations, which is 6 of them, and then find the biggest one. If you are given n numbers, then this question becomes much harder. Okay? So the fact that this question is only 6 numbers make it quite easy. You can basically do this by brute force. The only tricky part is knowing how to convert from decimal number to binary string, and then vice versa from binary string back to decimal number. Okay. Just make sure there are no questions. Oh, Google CEO, I came here to cheat. Oh no. Yeah. I'm sorry, Google CEO. This is probably not the place you want to cheat. There's no cheating here. And if you want to cheat, you should find somebody who is a little bit smarter than me to cheat off. I'm just a common person. I'm not going to be very helpful if you want to cheat from me. Okay, so question 2. Remove methods. Question 2, remove methods from project. You are maintaining a project that has n methods numbered 0 to n-1. You're given 2 integers, n and k. A 2-dimensional array invocations where a, b indicates that method A invokes method B. This is basically a graph, right? This is your edge list. These are the list of edges, and this is basically a graph problem. You can sort of ignore the project and the core, and all those things are just fancy stories that you can completely ignore. Just think of this as a graph problem. There's a known bug in method k. Method k, along with any method invoked by it, either directly or indirectly, are considered suspicious, and we aim to remove them. So basically, in the graph, you find k, node k, and then you find all the children, all the descendants of k, everybody that's reachable from k. A group of method can be removed if no method outside the group invokes method within it. So return an array containing all remaining methods after removing suspicious methods. Or if it's not possible, remove all possible suspicious methods. None should be removed. This is, again, the hardest part about these questions is not the programming, is the stupid, is the English, right? I kind of hate how obtuse they describe this, right? English is not my first language, so it is what it is. Okay, so let's look at some examples. In this example, k equals to 1. What this means that k is now suspicious, and then everybody that k calls to 2 is also suspicious. Okay, these guys need to be removed. But if you look up, you scroll up, the rule is if it's not possible to remove all the suspicious methods, none should be removed. Can you remove 1 and 2? You actually cannot, because there are other people who are good calling it. So in this case, it's impossible to remove bad methods. So in this case, in example 1, it's impossible. So what you want to do when it's impossible, you just don't remove anybody. So methods 2 are suspicious but directly invoke, which are not suspicious. We hence remove without any, because this is impossible. The English makes it a little bit obtuse, but once you look at the example carefully, you should be able to figure it out. Example 2, k is 0, so this is bad. He calls 1, 1 is bad. He calls 2, 2 is also bad. In this case, can you remove all 3 of them? Yes, you can remove all 3 of them, because these guys, don't call them at all. They are not connected in the graph. So you're left with 3 and 4, which you answer here. Let's go through one more example. In this example, k equals to 2, 2 is bad. So 2 is bad, right? So 2 connected to 0, 0 bad. 0 connected to 1, 1 also bad. In this case, all are bad. Is there anybody calling a bad? No, nobody is calling the bads. No good is calling the bads. So we can remove all of them. And the answer is nothing left. Okay, so from here we derive 2 rules. Our strategy is find all the methods who are suspicious. 2 is we need to check that non-suspicious do not call suspicious. If any non-suspicious calls a suspicious, then we return everybody. Right? We just say, oh, okay, we bail out. Okay? So that's the general strategy. So here's the code that I have to do it. So step 1 is basically to find all the suspicious. So step 1, actually step 0, is to transform the edge list into a adjacency matrix. I don't like edge list. Edge list is one of the most useless representations. Adjacency matrix is so much, 99% of the time is much better. Next thing I do is then I want to calculate the set of suspicious nodes. So to do this, I basically do breadth first search, depth first search, whatever you call it, doesn't matter. So do some kind of breadth first search or depth first search. This is fairly standard, and then you can find everybody who's suspicious, right? If you need help with this breadth first or depth first search, let me know in the comments. I will have a separate video. I don't want to go through it here. So once you want to do that, you can now go through, you can create this thing called results. You go through all the nodes because you know the size of nodes, and note that not all nodes appear in the invocations. So some nodes do not appear in the invocation, and hence they don't appear in your adjacency matrix. So you have to be very careful about these guys. They are sort of hidden. So what you want to do is first, if it doesn't appear in invocations at all, then you result append. If not, then you check. You want to make sure this guy, if he's a good guy, if he's a bad guy, then don't do anything. If he's a good guy, if he's a good guy, then make sure that he does not connect to anybody who's a bad guy. If he connects to anybody who's a bad guy, then you return range n. And range n is basically everybody. And that should give you the answer. Okay. Let me check if there's any questions about this. Nope. Okay. So question 3. Question 3, I'm pretty sure I'm close to it. But question 3 is really interesting. Let's go through it together. So you're given a 2-dimensional integer array edges representing an undirected graph having n nodes, where edges is uv. So this again, you're given an edge list. You want to construct a 2D grid that satisfies these conditions. The grid contains all nodes. Everybody are exactly once. 2 nodes are in the adjacent cell if and only if there's an edge between them and edges. So it's guaranteed that edges can form a 2D grid that satisfies these conditions. Okay, so what this is talking about is that you have a bunch of nodes, right? You have a bunch of nodes. In this case, you have 0, 1, 2, 3. 0 is connected to 1 and 2. 2 and 3. Yeah. So you want to arrange them into a box. So this case looks like, oh, it's fairly trivial, right? Just arrange it in a box. Well, it's not that trivial. Suppose you have 0, 1, 3, 2. Right? 0 is connected to 1 and 2. 2 is connected to 3. 3 is connected to 1. So you arrange this into a box. So you sort of have to untangle them a little bit, right? It's not that straightforward. Because the graph doesn't correspond to the nice grid here. The graph can be tangled up. These guys can move around. So the graph has to be untangled in a sense. So how do you do that? Well, one observation that I made is that you have this idea of corners. If you actually count how many neighbors each person have, you can realize where they are in the grid. So a more general idea is this one. Let's say 3 by 3 grid. Okay? Let's say, or even if I have a pretty big grid. Suppose I have a pretty big grid. Okay? And then each square is connected to its neighbors. So every node here is connected to its neighbors. Every node here is connected to neighbors. Okay, now how many neighbors do the corner nodes have? All the corner nodes here will have 2 neighbors each. So if you have edge list or adjacency matrix, doesn't matter. I tend to use adjacency matrix. You will see there are 4 nodes with 2 neighbors each. And those 4 nodes are going to be your corners. What about the edges? The edges actually have 3 neighbors each. So you see a node with 3 neighbors, that's going to be an edge. And then, finally, everybody in the middle have 4 neighbors each. So using this, you can actually figure out, right, based on this long convoluted thing, you can actually figure out where the corners are. So looking at this thing, you just count which numbers appear exactly twice. So for instance, 8 appears here and here. So 8 and nowhere else. So 8 is a corner. Right? So with that information, you can actually start by placing 8. Somewhere in a corner. Yeah, you can start by placing 8 somewhere in a corner. And then you want to find what are the people connected to 8. So 8 is connected to 6. 6 and is connected to 7. Now you'll notice that both 6 and 7 are edges. So 6 appears where? 6 appears here, here, and here. So 6 is going to be some kind of a side because 6 has 3. So you sort of progress this way. So 6 has 3, so 6 has to be a side, right? And now you look for 6. Who is 6 neighbors? 6 neighbors are 3 and 4. 6 neighbors is 3 and 4. But 3, yeah, 6 neighbors are 3. 3 has 2 neighbors, so 3 is a corner. 4 has 4 neighbors, so 4 is actually a center. So using this information, you can then place 3 here. And you can place 4 here. Okay? So that's how you sort of fill in the grid. So you start by finding a corner. And then from the corner, you sort of fill in the side. You fill in one side. Doesn't matter which side you fill in, right? Because you do 8, 6, 3 is one side. 5, 2, 3 is also a side. In this particular question, they don't care how you transpose your your final result. You can flip it around in any number of ways. It's all going to be accepted. Okay? But the basic idea is you start by identifying the corners, and then you identify the sides. And you can do this, all of this, based on how many neighbors they have. Okay. Now, we're going to do this in for the slightly simpler case. For this case, because it's only one row or one column, whatever you weigh, you'll notice that the corners here have one neighbor, and the people in the middle have two neighbors. Okay? So this is the same idea. This is the same idea. In this case, this is a row. So what you want to do is start by finding a corner. Which corners only have one neighbor. So you find the people with one neighbor. Let's say I start with 0. 0 has one neighbor. And 0's neighbor is 1. So 0 goes to 1. 1 has two neighbors. One's neighbor is 0 and 3. Well, 0 is already used. So we place 3 on the other side. So 0, 1, 3. And now 3's neighbors are 1 and 2. 1 is already used. So we know 2 has to be on the other side. So we have some kind of used set that tells us who is being used. We start with a corner. And then go along the sides until you reach the other corner. Okay? And this will allow you to fill in one row. So if your problem only has one row, that's where you're done. So you start with a corner. For problems with only one row, the corners have one neighbor and the middles have two neighbors. You find middle, then you find next middle, find next until you reach the corner, and then that will be your answer. Okay? This is how you're going to do it for the first one. Now coming back to this two-dimensional grid, you sort of do the same strategy. You start with a corner. In this case, the corners have two sides, two neighbors. The sides have three neighbors. Okay, so the corners are 8, 3, 1, 5. So let's say you start with 8. Okay, 8 is corner. You want to now look for a side or another corner. So it doesn't matter which one you pick, 6 or 7. It doesn't matter. You just transpose matrix, transpose rectangle. In this case, I pick 6. 6 is a side, right? So 6 has 4, 8, and 3. I cannot pick a 4 because 4 is an inner. 4 is inner and 4 has 4 neighbors. So I have to pick somebody with 3 neighbors or 2 neighbors. No one else next to 6 has 3 neighbors, but 3 has 2 neighbors. So 3 is a 2 neighbor, is a corner. So I start with a corner. I find a side based on how many neighbors they have. I keep going until I find next corner. So this fills in the first row. What do you do after that? You fill in the second row, right? So the second row, find the previous rows. What do you call that? You go to the previous row. You look at which children they have that is not being used, and then you pick one. In this case, the children that is not being used is 7. And what do you do next? You go and you see what are the sort of children of 7. Oh, well, 4. And then you can go to 2. It's the same logic. And then now 7 goes to 1, 0, 5. Okay? And that's how you get your matrix. Now, there's one more thing that you need to take note of. Which is if 9, 7, let's say 4, 2, 10 or whatever. Which is, if I'm here, I don't know if I should pick 2 or pick 0. Because the next guy, both of these have 4 connectors. Both of these have 4 neighbors. Both of these guys are inners. So the way to do that is find your next guy is going to be somebody with 4 neighbors, and one of the neighbors is your previous guy. Because what you want to do is you want to go row by row, right? Once you solve this row, you have to check you have the previous row to guide you. So this is the only sort of slightly tricky part about this problem. Okay, so I've talked a lot. And I think I scare most people away. But what I want to do now is to actually go through my answer, which I thought I was pretty close, but apparently I didn't manage to finish up in time. This is how I did it. So the first thing I do is quick escape. The first thing I do is to do a matrix. I turn the edge list into a matrix. So I have all the matrices. The next thing I do is to count my neighbors. Okay, I have 1s, 2s, 3s, and 4s. For each U in matrix, I check if this has one neighbor, I put in 1s, 2 neighbors, 3s, and 4s. So I know for each node how many neighbors there are. So now this is like just sanity check, make sure I'm correct. Now I want to distinguish between the two situations. Is this a line like this? Like in example 2, or is it a grid, a rectangle in example 3? Okay, if it's a line, it's slightly easier. If it's a grid, it's slightly harder. So what I do now is first so how do I tell whether it's a line? Well, I check the neighbors, right? If it's a line, there should be 2 nodes with 1 neighbor each, and there are 0 nodes with 4 neighbors each. This tells me that this is a line. There should be 0 nodes with 3 neighbors each also. It should be 2 nodes with 1, and everybody else will have 2. Okay? If I found a line, what do I do? Is first I start with I just pick anybody who is a 1. So the 1s are my corners. I pick a corner. I use a used set to keep track of who's being used. And then I keep doing this, right? I just keep going down. While not done, I find all of this current children. So I start with, let's say 4. Let's say I have 4. Current is 4. Current equals 1, 0. Okay. So in this while loop, I look at his children and I check if his children is in done. If it's not in done, I connect to it and then I move my current to the next one. And then 2 has 2 children, 4 and 2 neighbors, 4 and 3. But I pick the one that's not done, and then I move my current. And I keep going until I have the entire row. So this is what this part of the code is doing. Okay? If it's a rectangle, I actually start by doing the same thing first. I find the first row. So it's a rectangle. The first row, the corners will be a 2. The corners will be a 2. So just now corners is a 1. Now corners is a 2. And what I do is I go down the row. I look for each of his neighbors. If it's used, I don't care. Otherwise, I want to find a 3 that's not used. That will be a side, and I add it. If it's a 2s, it means I've reached the opposite corner, which means I'm done. Okay? And so what I want to do is to first create the first row. So my first row will be something like 8, 6, 3. Okay? Yeah. And after I create my first row, I'm going to now create multiple rows. I'm going to keep going until I reach the last line. How do I know if I reach the last line? Well, the neighbors is 2, right? So I have this thing called previous row, which is what I used. So I find the previous row, I find a neighbor that is not used. So 8 has 6 and 7. The only neighbor is not in use is 7. And then from here, I write some code. Here I write some code to say, okay, I check all my neighbors. I need my neighbor to be if it's the last row, it needs to be a 3. If it's not, it's like here in the middle. It needs to be a 4, which means it has 4 neighbors. I check there is the right count, and I check that it's connected to the previous. I need to make sure that whatever number I put here is also connected. Is connected to 6. It's connected to 6 and 7. Yeah. Okay. So that's the basic thing. So if you do that, you fill it all the way in, this should give you the answer. Right? If it doesn't match the counts, if it's not the case that it matches the counts, it doesn't have the right number of corners, then I just return this. This tells me that there's some error somewhere. But this should never happen because the program will, the question guarantees that you will have a valid count. Yeah. Okay. So that's all for question 3. Let's go on to question 4. Question 4, actually, I didn't try at all. So to be honest, your guess is probably as good as mine. Maybe even better. My guess, if I were... Okay, question 4. Let me explain the question first. You are given an integer array nums of length n and an integer array queries. GCD pairs denote an array obtained by calculating GCD of all possible pairs, and then sorting these things in ascending order. For each query qi, you need to find the element at index queries I in GCD pairs. So for instance, 2, 3, and 4, the 3 pairs are 2, 3, 3, 4, and 2, 4. So the GCD is 1. This is also 1, and this is 2. And then you sort them. You get 1, 1, 2. GCD pairs. Right? 1, 1, 2. So what you want is to find the 0th, second, and second. Oh, wow. Why is it 2 and 2? This is so weird. Okay. So this is 0th. This is second and second. So it's 1, 2, 2 is your answer. Okay. So the trick about this question is basically how to calculate the GCDs very fast. If you do like if you calculate every pair of GCDs, it's going to be super slow. And in any case, if you look at this is 10 to the power 5. That's not going to work. You cannot have an n square solution. And this is not just n square. This is like n square. And it depends on the size of the numbers, because larger numbers take longer to calculate GCD. So good luck to you. That's not going to work. So I don't know what the solution is, but my guess is it's going to be some kind of tree. Some kind of factor tree. So what do I mean by factor tree? Basically, you want to arrange the numbers that you have. Arrange the numbers you have based on their factors. So 2, 3 are prime. 4 is a multiple of 2, so it goes here, so it's descendant. Okay? So 4, 4, 2, 1. So 1 is everybody's factor. So 2 is a multiple of 1. 4 and 4 are multiples of 2. Okay? So with this, once you have the factor tree, then it becomes easy to calculate. How do I say? It becomes easy to calculate how many. First of all, you can easily determine how many pairs there are, what their GCD pairs are, right? But in fact, you don't even have to find the GCD pairs. There's an even faster way. So basically, once you have this factor tree, you want to find the GCD of any two numbers, let's say 4 and 4. You just find their common parent. So in this case, 2 is their common parent. So the GCD of 4 and 4 is 2. This factor tree allows you to very quickly determine the GCD of any two pair of numbers. But the thing is, you don't even have to do that. You don't actually have to determine what the GCDs are. You just need to know. You just need to know how many copies are there. So to know how many copies there are, basically boils down to how many pairs of nodes has the largest common parent. And that depends on the size of the tree. So for instance, let me choose a different color. So for instance, 4 has no descendant, right? 4 has no descendant, so 4 will never be a GCD. There are 0 GCDs. There are 0 pairs whose GCD is 4. Likewise, this 4 also here has no child, right? So this one also 0 pairs whose GCD is 4. This 2 here has it should have 3 pairs. Oh, it has 2 pairs. Wait, why is it 2 pairs? Oh, sorry. These two are also. Yeah, this is a bit tricky. These two also have a line between them. I don't know how to draw this. I have to think a little bit how to represent this correctly. But the basic idea is you have to draw some kind of graph that tells you, or tree is directed acyclic graph that tells you how many copies there are. So this guy, 2, has actually 1 and 2. So it has 2 pairs whose GCD are value 2. Yeah? So how do you know this? Basically, you take the size of the left tree, multiplied by the size of the right tree, plus because size of the left tree, because any node in the left tree and any node in the right tree, if you want to take their GCD will be 2, plus yourself plus size of children. Okay, so what this means is which pairs have 2 as a GCD? Any pair where 1 is in the left and 1 is in the right. So anybody in the left subtree of 2, and anybody in the right subtree of 2, their GCD will be 2. Okay, this is a bad example because the 4 and 4 is kind of weird. If I should change this to 4 and 6. Or 2 plus any child of 2. So how many pairs will have GCD of 2? Well, the size of the 2 subtrees multiplied together, 1 and 1. In this case, this is not a good example because these guys are the same number. Plus any pair, any child and itself. So the size of all its children, excluding itself. Okay, so same thing with GCD of 1. How many left subtree? There's just 1 left subtree. There's nothing in the right subtree. So this first condition is 0. Plus itself, which is 1 times the size of his children. So there are 3 children. So there's 3. So you can see there are 3 pairs whose GCD is 3. And all of them is like 3 is 1 plus some number. Yeah. So I believe this is the right way to do it. So once you have this information, you just calculate how many there are in each. And then you can sort of arrange all the numbers. You sort all the numbers by size, right? And then you can start to do something clever. You know, if you need to know query number 5 or query number 10 million, then you start at the smallest number. You see, oh, this guy has, 600 pairs. Then you reduce that by 600. You go to the next number and yeah. So you can basically, then once you have this number out, right, you can then say, okay, 1 has 3 pairs. 2 has, in this case, 2 pairs. 4 has 1 pair. So if I want to find the third pair, it's going to be 1. If you want to find the 5th pair, it's going to be 2. Right? You can go down this list and basically do some kind of, you can do a binary search if you want. If not, then you just go down a list. It's going to be quite fast compared to the normal n squared solution. So I think this is the right way to do it. Somebody can try it out and fact check me, but I'm pretty sure, I'm like 80% sure that this will work. So create some kind of tree, and then for each node, use the tree to calculate how many pairs have this number as its GCD. I think there are some kinks to be worked out. For instance, this 4, and also the fact that the GCD doesn't have to appear in the list. Yeah. So there are some kinks to work out, but I strongly suspect that there's some kind of tree involved, but maybe I'm wrong. Okay, so that brings me to the end of the live stream. I hope this was educational for people. This is quite a difficult, I would say that this is a really, for me, difficult contest. But I hope that folks have fun. I hope that folks did a little bit better than I do. In any case, I hope to see all of you again next week. And that's all for now. I'm signing out. Bye-bye.